Hello and welcome. Today's video is 3.7 on word puzzles. We're continuing to talk about word puzzles, specifically in this case about consecutive integer and variables on both sides of equations types of problems. So this is still underneath our Unit 3 of equation solving, and you can find pizzazz pages 47 and 48 to have many examples. We're going to go ahead and take a look at some vocabulary. So first of all, we're going to take a look at consecutive integer. And consecutive integer means that we have, I'm going to make this a little bit larger, integers that follow each other in order. I'm going to use this in capitals, so let me go ahead and do that. Integers that follow each other in order. So an example of consecutive integers could Okay, so the key concept for this, it tells us that we're working using the same method that we have in our notes of 3.5 that we introduced the word problems with. So identifying the variables, writing the equation, solving, checking, and answering the question that was asked. So our first question or example that we're going to use is find two consecutive integers whose sum is negative 29. And so we're going to talk, the things that we don't know are the first integer and the second integer. Because they're consecutive, we can use the concept of x and x plus 1. I'm going to give myself a little bit more space here. So in doing so, I'm going to write down x for the first integer and y for that second integer, because I have two numbers that I don't know. And because I know that they are consecutive integers, I can rewrite y to be x plus 1. Now, if I can do that, then I'm going to go ahead and identify that I recognize sum, so this word right here, as the addition of these two numbers. So I'm going to write x plus y is equal to negative 29. And then fill in for y the concept of x plus 1, being the next number or integer that follows the first. So here I can simplify by combining like terms. I have 2x plus 1 is equal to negative 29. And then I can subtract 1 from both sides to give me 2x. Let's make that look like a 2. 2x is equal to negative 30. Dividing both sides by 2, I find out that x is a negative 15. Okay, the mistake that many people make when we work with negative numbers is to actually increase their value. The next number after negative 15 in a number line is not, I repeat, it is not negative 16. So a way to always make sure that we're working there, intuitively, we know it's either going to be negative 16 or negative 14. And the way to always get it correct is to go back into the original equation, this idea right up here. So if I go back to y is equal to x plus 1, I can say y is equal to negative 15 plus 1. Here, this is going to give me y is equal to negative 14. So in doing this, I can go ahead and check my answers. So I'm going to do a check, because if I add these two numbers together, they should, if they check out, they should add to negative 29. So if I take x plus y is equal to 29 negative, I'm doing the check. And again, with this check, I'm going to take a look and say x I found to be negative 15 and y I found to be negative 14. Does this in fact equal negative 29? I'm running a little out of room, so I'm going to reevaluate where I am. Let's do it this way. There, we can fit it all in that direction. And so if I put this into my calculator, I can always double check it that way, and I do find that negative 29 is the sum of negative 15 and negative 14. So we've checked our solutions. That's an excellent next step, and from there we're going to go ahead and see if we can answer the actual problem. It told us in the question, it wanted us to find two consecutive integers. So in a sentence, I'm going to write down that two consecutive integers are we don't use a Q, consecutive. So two consecutive integers whose sum is negative 29 are negative 15 and negative 14. Excellent. Let's go ahead and take a look at the next example we have going. So when we flip our sheet, it tells us, for example 2. And we're going to want to title this section title up here. So we're going to want to say 3.7 consecutive integer problems. I'm going to go consecutive int / VOBS. Okay. So in example 2, it tells me to find 3 consecutive integers such that a number of twice the smallest and 3 times the largest is 126. Okay, so I know I'm working with 3 numbers. And when I go about doing this, I'm going to start by saying my first number, second number, and third number. My first number I'm going to write as x, the second number as y, and the third number as z. Now in doing this, I'm going to take a look, and because they are consecutive integers and not worried about odd or even, if my first number is x, my second number is the same thing as x plus 1, because it's the next integer that follows. If I want to take a look, and I can always guess this, if I start with 5, the next integer would be 6, and the next integer after that would be 7. If I take a look, to get from 5 to 6, I can take 5 and add 1. To get from 5 to 7, I can take 5 and add 2. So for our first number, if we have x, the second number is x plus 1, and the third number is then going to be x plus 2, filling in that slotted area. So let's go ahead, and I'm going to erase this so that we have some room to actually write in our problem. The next thing I'm going to do is recognize that I'm not just taking the sum of all 3 numbers, is that it's asking for a very specific sum. And it's asking for twice the smallest, so 2, and the smallest number is always my first, so 2x, and, so that's the plus, that's and is plus, 3 times the largest. If I take 3 times the largest, I'm going to have 3 times z, which is another way of saying 3 times the quantity of x plus 2. We'll get there in a moment. And we know that is means equals. $126. So let's write this expression that we now have. We were told that twice the smallest and, which is the sum, 3 times the largest is 126. So in doing this, I'm going to then substitute z for the idea of x plus 2. That idea right there is going to go in there. So in doing that, let's go ahead and write 2x, and that looks like a z, so let's make it look more like a 2. 2x plus 3 times the quantity. And I'm going to plug this in as something a little different color just to make sure we can recognize I'm using this. So x plus 2. Now to simplify this, I need to use my distributive property, so I'm going to leave the 2x there and make this a 3x plus 6 because 3 times x is 3x and 3 times 2 is a positive 6. Combining like terms, I get 5x plus 6 is equal to 12. I can subtract 6 on both sides, and I get 5x is equal to 6. When I take a look at this, I had erased, this is not equal to 12, it's actually equal to 126. So I apparently erased the extra 6 on there. So if I subtract 6 from 126, I'm going to have a different number. I'm going to have 120. That makes a lot more sense. It looks like I accidentally erased the 6. So again, twice the second, or the smallest rather, twice the smallest plus 3 times the largest is equal to 126. Glad we found that quick error. And we're going to go ahead and divide by 5 on both sides and find out that x is equal to 24. If I go ahead and know that the next integer after 24 is 25, and the next integer after that is 26, just because of my intuition, we can always go back and check that based on our math. We have this guess that y is equal to 25, and then z would be equal to 26. In order to check that, we can use the math right here and right here to say 24 plus 1, yep, that's 25. And 24 plus 2, yep, that's 26. We can also do the check back into the original equation up here. So let's go ahead and do that actual check to make sure that if I take 2 times the smallest plus 3 times the largest, I in fact get 126. So 2 times 24 plus 3 times 26 hopefully gives us to 126. When I double 24, I get 48. And when I take 3 times 26, I get 78. And when I add those two pieces together, I do in fact get 126. so it checked out for us. So the three integers that I found, so I'm going to write the three integers are 24, 25, and 26. Excellent. Now, example number 3 is a try on your own. It says find 3 consecutive even integers. I want you to be really careful here. We're talking about even integers. So I might even get you started by writing out the first, second, and third numbers and just helping you allocate that way. So if we do this, let's go ahead and indicate that the first number is x, the second number is y, and the third number as z. From here, I'm going to recognize that if I'm working with even integers, an example could be 10, 12, 14, 16, 18, etc. Those are my even integers. They could also be negative numbers as long as they were even, and they can always include 0 as well. So for an even number, I could have it say -4, -2, 0, 2, 4, 6, etc., etc. And they always can move ahead. So if I'm working in that direction, if the first one is x, then I'm going to use the idea of x plus 2. Essentially, if I start with 10, in order to get to 12, I need to add 10 plus 2. And in order to get from 10 to 14, we'll go the other way so we can see the whole thing, I'm going to have to add 10 plus 4. So in using that, that's why I have the x plus 2, and my third number will be x plus 4. And again, that's in the very beginning of the sheet. Go ahead and pause the video at this time and try this on your own. Again, we're working with the sum if the smallest and the largest is 36. So we're going to be adding the smallest, which is x, and the largest, which is z. Thanks for pausing and trying that one on your own. We're going to go ahead to example number 4. So example number 4 says 10 increased by 6 times a number is the same as 4 less than 4 times the number. We're going to find the number. This is the side in which we're really using variables on both sides. So I'm going to write that on the top as word problems. VOBS. And this is 3.7 to help us remember where we're at. So this is a little bit more straightforward, and we're working on just a straight translation. So if I take a look at this, this doesn't have anything to do with consecutive integers. We're just working now with this word problem. So if I take 10 increased by, I'm going to write 10 plus. The next thing says 6 times a number. We usually write as 6x. Is the same as, we can write as equals. So I'm going to write that down. 4 less than 4 times. Alright, if I work with less than, I'm subtracting, but it tells me that I need to flip-flop some things around. So I'm going to write -4 to represent this less than, 4 less than. And then the last section says 4 times the number. So that's going to be a 4x. So I do in fact have variables on both sides of the equation. So here I've got a 6x on that side, and here I've got a 4x on that side. I cannot combine like terms, so I need to move these variables around. The first thing I'm going to do, I like to move mine over to the left side, so I'm going to move this 4x. And the 4x is going to then give me 10 plus 2x is equal to a negative 4. Don't forget that negative kind of hanging out right up here. Solving, I'm going to subtract 10 on both sides. Ooh, let's actually get a pen, not the highlighter. And that gives me 2x is equal to negative 14. Intuition tells me that x is going to be negative 7, so if I divide by 2 on both sides, I do find that x is equal to negative 7. Now, in this way, if I take a look, so x is equal to negative 7, I can go ahead and check this based on the answer in which I have. It's also good to double check to see if that really makes sense. So, if I take 6 times that number, and add it by 10, so 10 plus 6 times negative 7. That side is going to let me know I get 10 plus negative 42. So this gives me negative 32 on that side. If I go ahead and say 4 times negative 7 is minus 4, this gives me negative 28 minus 4, and will in fact give me negative 32. Lucky for us, it did check out. For number 5, I'm asking you to translate this problem only. We will check it in class. So the translation I'm asking you to translate says 12 less than a number is the same as 6 decreased by 8 times a number. Find the number. Now I'm going to give you a hint here. The same as is where we have the equal sign. So try and take a look and translate that. We will check that your translation is solid and continue to solve in class tomorrow. Thanks so much for your time for tuning in.